Okay, so 4.4, okay, it's kind of a continuation of 4.3. It's solving ax squared plus bx plus c is equal to 0 by factoring. Okay, so last section or whatever, okay, at the end of the semester, the only difference was there wasn't an a in front of the x squared. Okay, it was just like a 1 or a -1. But now there could be like 2, -5, 10, like different numbers in front. Okay, process is basically still the same. It just looks slightly different. So I'm going to do a review of a problem that like we would have done at the end of last semester, and then we'll start with the new stuff so that you kind of get a refresher on the process, because it's been a while. It's been 3 weeks, right? If not more than that, since y'all took your exam.
I remember how to factor.
If I retook the exam right now, I would totally go.
Alright, so if you had something like x squared plus 7x plus 12, okay, and I wanted you to factor this, okay, we would look at this term, okay, the 12. We would figure out what factors of 12 add up to give you 7. So what would that be?
4 and 3.
Okay, 4 and 3. So then x squared plus, it really doesn't matter which one you do where, so 4x plus 3x plus 12. We're going to pull something out of this, so what can we take out of these?
X.
Okay, so x times x plus 4. And then what do we need to take out of this?
3.
3 times x plus 4. Since both of these things match, we're good. So then our factors are x plus 3 and x plus 4. Okay, so that was the type we did last semester. So the difference now is the number in front of the x is going to, or the x squared, sorry, is going to get multiplied by this number. And then that's what's going to break down to give us our factors that add up to be the middle. Okay. So, like I said, there's really no notes for this section because it's just a continuation of 4.3. So all of those note things still apply. You can still have special types with this. They just look slightly different now because there's a number in front of them, but the process is still the same. So, number 4, you just say factor the expression. If it can't be factored, just say not factorable. So, 3n squared plus 7n plus 4. Okay, so we call this the arch method because what you're doing is you're taking this number in front, multiplying it by the number at the end. So you're going to have, I didn't even plan to do that, but it's going to be very similar to the problem we just did. So 3 times 4, so 12. So now we're looking for the factors of those two numbers that are multiplied together to give you 7, which I genuinely didn't plan that, I promise. I just picked a random problem. 4 and 3. Okay, in this case, when you're doing this type, it does matter where you put the numbers. Okay? Because your factors are going to be off if you don't put them in the right spot. So you're going to, now, if you have like a 6 and a 12, okay, and you've got like 2 and 3 or something like that, probably doesn't really matter that much. But with this one, I need to put the 3 with the 3 and the 4 with the 4. Okay, so when I write this down, I'm going to do 3n squared, okay, so all the numbers get copied down, plus 3n plus 4n plus 4. Okay, and then at this point, okay, I'm not sure if I've really used this term before with this specific stuff, but factor by grouping, okay, is what we call this step where you're grouping the stuff together. Okay, a lot of times when I'm doing the ones that don't have a number in front, I actually don't write it this way. Just because I've done it for so long, I actually go basically straight from here down to here. But it's good that you see this step, especially when we're first doing it, because like when we get to this section, you have to do it that way. There's not a way to do these without factor by grouping. Okay, so we group these two together and these two together. So what can I take out of this one? 3n, which leaves me with n plus 1. And then what can I take out of this one? 4, which leaves me with n plus 1. Since they match, we get 3n plus 4 times n plus 1. Okay. And then if you're like, well, I don't know if I actually factored that right, remember, if you FOIL it, you should get back to what you started with. Okay. All right. Let's see. Number 6. 6p squared plus 5p plus 1. So I'm going to have 6 times 1. Okay, so factors of 6 that add up to give you 5.
2 and 3.
Okay, 2 and 3. Okay, don't be fooled and be like, oh, it's just 6 and 1. One of those would have to be negative, and then your signs wouldn't match up. So make sure you pay attention to signs, okay? So 2 and 3, both are going to be positive. This is one where it really doesn't matter which number goes with the 6, okay? Pick your favorite one. Which one do y'all want to go with the 6?
2.
All right, so 6p squared plus 2p plus 3p plus 1. So factor by grouping. What can I take out of the first two? 2p, leaving you with 3p plus 1. And then how about this one?
1.
Okay, so we're still taking out a 1, even though, like, you know, you have to take something out because there's got to be something to go with it, but it can just be a 1. So then 3p plus 1, so those match. So 2p plus 1, 3p plus 1. Gives you your answer.
It's not hard. Same thing, basically.
Yeah, it's the same thing. It just it just adds that extra step. Like every once in a while, they'll give you some really weird numbers that it's just like hard to come up with their factors, which is where like you might need a prime factor, because right now you can just see what the factors are.
Mm-hmm.
But if you had like 128, you may not see what the factors are right off the top. You know. And this one, it didn't work, but sometimes it will work where just these two numbers are your two factors, which works out really nicely. So I always look at those first and be like, oh, does this work? And if it doesn't, then I move on and try something different. Okay, let's do 10. This first section of them is like the easier ones, I guess. So I'll try to get one that's a little harder here. 14m squared plus m minus 3. So now I have 14 and I have negative 3. Okay, so that's going to give me negative 42. Okay, 14 and 3 do not give me 1. So I'm looking for factors that when one is going to have to be positive and one's going to have to be negative, the bigger number needs to be positive
7
because this is positive.
and -6.
Okay, 7 and negative 6. So 7 and negative 6. And when you get to ones like this, I would say this is more important that you go through and you check at the end. Okay, I don't require you to check it, but it's a very high recommendation because pretty much guarantee you get the problem right. So, see with this one, this is one where, does it technically matter which number goes where? No, but it makes the most sense to put 7 and 14 together and 3 and 6 together. Okay, it gives you things that are less weird, I guess. So 14m squared plus 7m minus 6m minus 3. So So grouping. So what can I take out of the first one? 7m, leaving you with 2m plus 1. And then what comes out of the next one?
-3.
-3, leaving you with 2m plus 1. So 7m minus 3 times 2m plus 1. And just for the fun of it, I'm going to check this one so that you have an example in your notes that we checked. So I'm going to FOIL. So 7m times 2m is 14m squared. 7m times 1 is 7m. -3 times 2m is -6m. -3 times 1 is -3. So 14m squared plus m minus 3. It's what I started with. So it's correct. Okay. All right, so we're going to move down to factoring the expression with special patterns. Okay, so this is going to be your difference of squares, okay, and your perfect square trinomial. So here, let's do our little refresher really quick. So if I gave you something like x squared minus 9, what does that factor into?
-3.
X -3 x plus 3.
X minus.
Yep, x minus 3 and x plus 3. Okay, and this is the difference of squares. And then those ones are a little easier to come up with off the top of my head. Hold on. I don't have to think as much for those ones. Something like t squared minus 16t plus 64. How would I factor that one? So the key that I'm seeing here is this term is squared, okay, and this term is squared. This middle term is 2 times the first term times this, what this term is that's being squared here, okay. Okay, and since this is negative, okay, t minus 8 squared, okay, and this is a perfect square trinomial.
Yeah. Same.
Yeah, sometimes it's hard to like explain like how you do it. It's just like you just do it. That's why I was like, well, the easiest way is to say the first term is squared and the last term is squared and then the other one.
It's all
So anyways,
squares.
so this is a more general thing, okay? But what this is going to go to show you is that I can throw a number in front of this x squared, okay? If I threw a 4 in front of here, then this would just be 2x minus 3 and 2x plus 3 is all that that's going to do, okay? So it doesn't really make them any harder. It's just an added number. Just basically something else to write. So jumping back to our examples then. 14, 4r squared minus 25. So what special type is this?
Difference of squares.
Okay, it's a difference of squares. And so then how would I factor this?
2r minus 5 and 2r plus 5.
Yep.
Yeah. That's not.
Let's see. 16, we've got 16s squared plus 8s plus 1. So So what type is this? What? What'd you say?
I was gonna say perfect square trinomial.
Yep.
Is it? Oh yeah, because the 16 and the 1.
Yeah, so remember 1 times 1 is just 1, so 1 is always something squared, so it can always work. So then what would this factor into?
4. It would be S. Wait.
So look at this pattern up here.
Yeah. So yeah, S plus 4 squared. Right? No.
4S.
Wait, no, that's wrong.
4S
yeah.
plus 8 squared.
4S plus
Maybe.
4S plus 1.
Plus 1. Oh, that one.
Okay, so remember we're only looking at the first and the third term in terms of the values that we're writing here, but the way to check that it's a perfect square trinomial, because sometimes they might give you one that looks like a perfect square trinomial but isn't. Okay, if this term here, okay, is squared and this one is squared, then the middle term is 2 times whatever this term is, okay, the thing that's being squared, times this term that's being squared. Okay, so the middle term is 2 times a times b. Okay, so the form is a squared plus 2 times a times b plus b squared. Okay, or obviously the signs could be different, but that's what it looks like. And then we square that whole piece. All right, do one more of the special ones. 20,
Special.
25t squared minus 30t plus 9.
Oh well, for the squared actually. So.
And if it helps you, you can rewrite these as what is being squared. So you could rewrite this as 5 squared t squared minus, if you want to do it so you can see it, 2 times 5 times 6. I don't know why I just wrote times 6, because that doesn't make sense. I was like, 5 times 6 is 30, and then I was like, wait, it's times 2. So 2 times 5 times 3, and then t plus 3 squared. Okay, if that helps you see it and you want to rewrite it, you can. Or you could even leave the middle term just as what it is, because you don't really need to worry about the middle term. So, other than if you're checking if it's a perfect square trinomial.
Oh, thanks.
You're welcome. That's how you help me.
That's true.
So the way you do these is it's literally just whatever the first term is. Okay, the whole thing's being squared. Okay, so what is the first term? What's being squared?
5
And
t.
okay, 5t. Okay, because this I could also rewrite as 5t
Which is
squared.
5t plus 3. Or no, oh, minus 3.
Okay, and again, you may want to check these. Okay, with the signs, that can be what throws us off.
It's just, I was thinking too hard.
Yeah.
All right, so we're gonna do. Okay, so that was all the special types that we're gonna do, like example wise. But we're gonna go down and we're gonna get some slightly harder factoring problems. Okay, so started out really easy, then we did special types. Now we're gonna get ones that are a little bit harder, but it's, I mean, they're still not bad. Like, don't get like scared or anything on me.
Like
They're,
no fractions.
they're not bad. They're
No
just
fractions.
oh no, not fractions.
Oh.
You can do them, but
But
they're
like,
not
we
fun.
don't want to.
No, I don't want to either.
That's a fun pastime. My new hobby, factoring fractions.
Factoring for fun.
Yeah.
Factoring fractions for fun.
Oh, that's a lot of F's.
Yeah. Anyways, okay. 12x squared minus 4x minus 40. Okay. So this might look a little scary at first glance. Okay. Those are some kind of big numbers, like 12 and 40, trying to figure out what in the world gives you -4. Kind Kind of brutal, right? Probably don't want to prime factor that. That would be awful.
I mean,
I will tell you, if I was going to prime factor it, I would not multiply 12 times 40 and then try to prime factor it. I would start out with 12 and 40, and then I would keep going to prime factor it, because there's no reason to multiply them when you're going to break them down again. But I'm not going to do that, because what do you notice about all of these numbers?
all factors of 4.
Okay.
All locations.
They're all factors of 4, so I can take a 4 out of everything, actually. So,
Legal?
yes, I'm not getting rid of it. I'm taking it out. I'm putting it out front. So 4 times, and then I like to use a bracket because I'm going to end up doing the parentheses for my factors. Okay, so taking a 4 out, that leaves me with 3x squared, negative x, and negative 10. So now this looks a little more reasonable to factor, right? So factors of 30, okay, I still, if I was going to do it, would do 3 and negative 10 as my factors, and then I would keep going, okay? So then, okay, you may see what the factors are without me having to write it, but just a refresher for prime factoring in case you get one that you need it. Okay, so what factors would give me negative 1? I've got to use all the numbers. Whatever numbers you use have to be multiplied to give you 30 in this case. Or negative 30, technically.
Then
So something needs to be positive, something needs to be negative. Since this term is negative, my bigger number needs to be negative.
so 3 of negative.
You multiply the 3 times the 2, and then you get 6, and then you make that negative.
Yep, so that's going to be negative, and then that one's going to be positive. Okay, you didn't necessarily, with 30, you may not have needed to prime factor it. It may have been easier to think about it as just come up with factors of 30 in your head.
Yes, it would.
But there will be some numbers that you aren't just going to be able to come up with them in your head. You're going to have to prime factor. So I was just trying to show you on an easier one what it looks like. So
Complicated.
the biggest problem, once you have pulled something out, a lot of people will forget the 4. The 4 is not gone. It's still attached. Okay, that's why I do the brackets with it. So 3x squared minus 6x plus 5x minus 10. Okay. I'm not going to lose the 4, so I'm going to keep bringing it down. So what can I take out of the first 2 then for my factor by
3x.
grouping? 3x. So that leaves me with x minus 2. What can I take out of this one?
You can take out 5.
5. So that leaves me with x minus 2. So then don't lose the 4. 4 times. And now I'll get rid of the bracket because I'm just going to switch over to parentheses. So 3x plus 5 and x minus 2. Okay, so if you go back and you check it, FOIL, and then multiply everything by 4, and you'll get back to 12x squared minus 4x minus 40.
So you don't actually have to multiply the 4 by those. You just leave
You just leave it out front.
Oh.
You want this as simple as possible. This is as simple as you can get.
Thought you had to like do something with the 4.
Yeah. Leave it there.
Yeah. You like
Just let it chill. Just whoop, all the way down.
Netflix and chill.
Whoa.
Maybe not.
Oh
All right, 26. 12m squared
Netflix and chill.
minus 36m plus 27. All right, so again, pretty big numbers, maybe a little terrifying. What can I take anything out? Sometimes it's not possible.
27, right?
9. Wait, can you?
Does 9 go into 12?
3.
Oh no, it does not.
Oh,
3.
3, so I'm going to take a 3 out.
I mean, if you're adding it.
So that gives you 4m squared minus 12m plus 9. So now my question is going to be, what do you notice about what's inside?
Oh, perfect trinomial.
Square.
Perfect square trinomial, so what does that factor into?
2m. Well, don't forget the 3, right? So 3 times
Yeah.
2m minus 3 squared.
Squared.
Yeah.
So a lot of times what actually happens is by pulling something out, it actually ends up giving you a special type.
I like.
Okay, so it'll actually make your life a little easier.
Cool.
All right, one more example, and then don't worry, you won't have to do all these problems in the next like 15 minutes. You're gonna have tomorrow to do these, and I'm gonna give you another review sheet that we'll do some off of tomorrow too. So you'll have plenty of time. I want to make sure factoring is something I want to make sure you have down, because if you can't factor,
You failed.
you can't really do anything else in math.
Yeah.
All right, so the last thing, you might remember we did a little bit with this with the last section, but actually solving the equation. So all it is factoring, setting it equal to 0, and actually solving for whatever the variable is. So I'm just going to do one of those because it's the same thing, just setting it equal to 0.
Yeah.
So 36 is 4x squared minus 20x plus 25 equal to 0.
It's a perfect square trinomial.
It is a perfect square trinomial. Works out quite nicely. So what does it give you?
2x minus 5 squared.
2x minus 5 squared is equal to 0. Okay, so then since it's being squared with the 0, it's just going to go away. So 2x minus 5 is equal to 0. 2x is equal to 5. And then x is equal to 5 halves. Okay.
I'd rather end with fractions than start with a fraction. Problem.
Had it not been a perfect square trinomial, like let's say there had been 2 factors, you would separate them and set them both equal to 0, and then you'd end up with 2 answers.
Can you
Okay.
solve it as just a regular problem? Like,
What do you mean?
do you have to solve it like a
Using
perfect
the
square
special?
trinomial? Like using the
Can
special?
you do all the steps basically?
Yeah, like can you just?
Like, could you have just regular factored it instead?
Yeah.
I mean, you could. It just more time.
I mean, I don't want to. It's just fun.
It just, yeah. I mean, you can. You always can. Like, if you don't recognize it's perfect square trinomial, like that's completely fine. Because I mean, if I'm telling you like on a test or a quiz, I'm not gonna say, oh, this is a special type. Factor this. I'm just gonna say factor the expression.
Oh.
Like this is like the one chapter where I don't necessarily copy and paste the directions from your textbook. I just say factor.
Good.
Because I want to see if you recognize, because sometimes I give an extra point if you recognize it's special. And you like write that it's a special type.
Oh my god.
Okay, so if you want to get started, you've got like 15 minutes. Tomorrow I am going to give you at least one worksheet, if not 2, in addition to this, but it's not like, I won't give you every problem on it. So
It's too much.
your problems are 3 through 27,
Just don't say.
every other odd. And then 33 and 37. Okay, so remember, this is like 3, skip 5, do 7. Okay, skip 9, do 11. I'm not 100% sure that it actually ends on 27, so if it ends on 25, like, just, it's fine. I never remember.
Yeah.
Mr. Cass is always really, really good at knowing, like, what number, because he just did it for so long. He always knew what numbers were in the every other odd. I have to, like, actually legitimately sit and say them, like, out what it is. Because he always assigned, like, every other odd. Like, yeah, anyways.
Did he
So-
give you guys a lot of homework?
Well, so,